Alright, so in this video I'm gonna be explaining another important article about model editing with the title Fixing Model Bugs with Natural Language Patches. This important paper in 2022 by Christopher Manning. Current approaches for fixing systematic problems in NLP models such as regex patches, fine-tuning on more data, are either brittle or labor-intensive and liable to shortcuts. In contrast, humans often provide corrections to each other through natural language. Taking inspiration from this, we explore natural language patches, declarative statements that allow developers to provide corrective feedback at the right level of abstraction, either overriding the model if a review gives 2 stars, the sentiment is negative, or providing additional information the model may lack. If something is described as the bomb, then it is good. When we model the task of determining if a patch applies separately from the task of integrating patch information, and show that with a small amount of synthetic data, we can teach models to effectively use real patches on real data. 1 to 7 patches improve accuracy by 1 to 4 accuracy points on different slices of a sentiment analysis dataset. So you see that the developers typically fix bugs by writing brittle regex patches or by fine-tuning on additional data which is prone to simple shortcuts. In contrast, natural language patches are more expensive than regexes and prevent shortcuts by abstractly specifying when they should be applied. So their proposed model uses a gating head. So this gating head here to predict whether a patch condition C applies to the input. That soft prediction is then used to combine the original model output with the output of an interpreter head that uses textual features from both the input as well as the patch consequent Q. So G is your gating, and does patch apply? Says does patch apply, and so F is the original output. So we present an approach for patching with natural language. Any patching system has to determine when a patch is relevant and how it should modify model behavior. So the setup is like this. We are given a model F mapping an input text to a probability distribution over its output space. The model contains bugs, defined as behaviors inconsistent with users' preferences or the ground truths, which we want to fix with a library of patches. So users explicitly indicate the condition under which each patch applies and the consequence of applying it, such that each patch is in the form if condition C, then consequence Q. So we apply, for example, a single patch C and Q. Q is the consequence. A single patch can be applied to any input X. So this is the fix of that. And we have a library of patches. So we find the most relevant patch for the given input. We use that to update the model. So patch types could be 2 categories. Override patches are of the form if condition, then label is L. They override the model's prediction on an input if the patch condition is true. For these patches, we do not use the interpreter head since I is L. So feature-based patches are of the form if condition then feature. They provide the model with a contextual feature hint in natural language. For example, the feature is food is good. For these patches, the model needs to integrate the hints with the original data, and thus both the gating and the interpreter heads are used. So you see the templates of different patches, some examples. For example, if aspect is good, then label is positive. We provide examples of patches that apply and patches that don't apply. The simplistic nature of these templates makes them easy to write without access to additional data sources or lexicons. And then we train the patchable models. The gating head G is trained with noise contrastive estimation to maximize this log of G, where negative here is just a randomly sampled set of negative conditions. So this figure shows a model can learn from just the labels that yummy and greasy are positive and negative words respectively, and learn to perfectly fit training data without ever using patch features. And then they talk about this entropy increasing transformations. They use T5 large in transformer library, and this is the patch templates used for patch fine-tuning stage for relation extraction. Each entity is sampled from a small list of names, and condition is a set of conditions derived from the keywords.